Okay, before we start, I'd just like to confirm that you guys can hear me clearly and see me as well. I'll be sharing my screen in a second. Hello, hello, testing. Can you guys hear me? Okay, perfect. Okay, sorry, again, we're running a few minutes late as per usual. The other classes just go a bit ahead each time and then it accumulates until it gets taken out on the poor grade 11s. Okay, I'm just sending the YouTube link and then we will begin, like once a few people are able to join the YouTube. Okay, just like one more minute and then we can start. Okay, assalamu alaikum and good morning to everyone. Welcome back to grade 11 maths by Inspired Teens. Today's lesson we are going to be covering, we're just going to be finishing some inequalities and then we're going to be starting exponents, I believe, right? So firstly, I hope you guys had a good week at school. Please do remember, if you guys have any questions, please feel free to ask them in the chat, in the Q&A, or on the YouTube chat if that's where you are. Also, please note that the notes, or basically the notes that you see me doing, will be uploaded to a Google Drive, and the link for the Google Drive is in the group description on WhatsApp. Okay, just two notes from last week. I believe it's this class that asked me for the timetable, and I said I'll give you the list of topics. Sorry, I didn't get down to doing that. I will definitely do today, inshallah. And secondly is the clarification of inequalities. I didn't get to that. I was supposed to release a video. I didn't. Sorry, I overestimated my time that I have in the week. So let's just go through it now, right? We're just going to clarify both. Someone had a question, how to do inequalities. They wanted me to go through the number line method again, and as well as most of you do parabola. So I just wanted to go through parabola as well. Okay, so let's begin, right? So let's look at this quadratic inequality. So we have x squared plus 5x is less than or equal to 4. Okay, so x squared plus 5 is less than or equal to 4. First step, we want to, in this case, we can identify that when we take the 4 over, we will have it in trinomial format. Okay, trinomial, basically a quadratic equation or quadratic inequality in that case. Okay, now remember, once we have it in its, let's just say, simplified form, we want to factorize. Why do we want to factorize in this case? We actually want to find the values that make this expression 0. Okay, so we call these the critical values. We want to find the critical values. Okay, so how could we find what makes this 0? We could firstly simply equate this to 0, or alternatively, we could also just, so if we want to equate it to 0, then we're going to be able to factorize. Alternatively, you could even factorize by keeping it as that and then just factorize, right? We'll just copy it when we're done with this one. So I'm going to now factorize this again. Why? I want to find the values that make this equation or this expression 0. So that's why I'm equating it to 0. Okay, we can go through that example. That's why I'm making it 0. Okay, so now I need to factorize this. So x and x, second sign is a plus, so both take the first one, which is a plus. So x plus, factors of 4 are either 4 and 1 or 2 and 2. If I take 2 and 2, I'm going to do outer inner, and I'm going to get 2 plus 2, which is plus 4, which is not the middle term. So I therefore need to choose 4 and 1. So I obviously then need to equate each factor to 0. And I'm going to have x is equal to -4 or x is equal to -1. Okay, so now I have identified the values that make this expression 0. These become my critical values. Alternatively, if you actually remember, we're going to do parabola first. If you actually remember from functions, okay, if you remember from functions, when we factorize like this, when we do trinomial factorization, when we equate our function to 0, we are solving for x-intercepts. Okay, so this is a similar concept. It's roots, x-intercepts, right? So what you can do is your x-axis, basically. Okay, and you need to draw a parabola graph. So are you going to draw a smiley face or are you going to draw a sad face? That just depends on a. The coefficient of x squared, is it positive or is it negative? In this case, it is positive. So I am going to draw a lovely looking parabola. Okay, alternatively, I'm not sure in what context you mean that. If you don't actually have to do a sad face, right? If you do have a negative x squared plus 5x plus 4 less than or equal to 0, what you could do, okay, is you could multiply everything by a negative. Okay, could multiply everything by a negative to make your x squared. You always want to keep your x squared positive in general, because like to factorize with that negative it's strange. It's going to make it a bit more weird. So then you can multiply everything by a negative. So when you multiply everything by a negative, all the signs change. So that becomes positive x squared, which is what we want, minus 5x minus 4. However, because we have multiplied, whenever you're dealing with inequalities, right, and you multiply or you divide by a negative, that's when you change the direction of the inequality. When you multiply or divide by a negative, okay, either side, both sides, take one to the left, take one to the right. If you're multiplying or dividing by a negative, you swap around the sign. Okay, and then this is if it was negative, then you can solve from there. Right, you now solve for that inequality. And again, you're going to have a smiley face parabola, but just to double check in case you didn't do the step and then you factorize with a negative, if a is negative, you have to do a sad face when it comes to this. But again, you are going to always try to change your x squared to positive. Hence, when you do this number line, you are going to have a smiley face parabola. So your critical values, you're actually going to place them as x-intercepts. Okay, your x-intercepts, the one that's most left is going to be the more negative, and therefore -4 and -1. Right, now we need to, so this is our parabola, okay? Our actual question / equation wanted to know the values of x, okay, for which x squared plus 5x plus 4 is less than 0. When we look at our parabola, remember when we consider our function being less than 0, our function being less than 0 is below the x-axis. When we do functions, we will cover this in detail. So therefore, when your inequality is less than 0, you are going to identify the parts of this graph which are below the x-axis. When the inequality is less than 0 or less than or equal to 0, it doesn't matter. Just we change our answer to include or exclude. When it is above, we are going to identify those parts of this parabola which are greater than or equal to 0. Okay, that's always the case. All right, so in this case, they want what? They want less than. So we are going to have to express this part of the graph. So you basically are identifying the part of the graph that's below. So when I previously highlighted, I highlighted just the entire below x-axis. But if I now want to highlight the part of the graph that's below the x-axis, I would highlight that part. And now I have to express it in terms of intervals. So basically, it's going to be between 4 and -1. Sorry, between -4 and -1. That's what my answer is going to be. So I'm going to say there's two ways you can do this. Where are we going to answer below it? I'm going to say whenever something is between, right? Remember, you put the variable between and then the number on the left and the number on the right. So I am going to say x is greater than or equal to -4, but less than or equal to -1. So this express, okay, x is between -4 and -1, including, why do I include? Remember, we discussed it last week. I erased it, but we have this and we have this. This is including, and this is excluding. Okay, remember with including and excluding, we have the bracket notation as well. Including, we use a little square bracket. Excluding, we use a circular bracket. Okay, why do we include in the specific question? Because the question includes. So when the question includes, we include. When the question excludes, we exclude with certain exceptions, which we'll go through, right? It's to the denominators. So that's how we could answer it. The first thing. Second interval method is x is an element of starting number and end number. Start number and end number. Okay, so the start, basically the yellow part. Okay, I'm just going to put square and circle brackets because that's just a general thing. We start at -4, end at -1. So x is an element of. Now I include -4 and I include -1 because in this case the question includes. Okay, so these are the two different ways that we could write our final answer, and that's expressed in terms of parabola. Now, same exact question, let's express it on the number line. So I identify my critical values. -4, let's use a line. Just my critical values, that's all I put. So this number line, I've actually separated into 3 parts. 1, which is everything before -4. 2, which is between -4 and -1. And 3, everything after -1. So basically now, you'll see it's like similar to parabola. I need to identify each segment. Is it positive or negative? What do I mean by is it positive or negative? How do I determine a positive or negative sign in each segment? The way we do that is we take a number that exists on this part of the number line. So for example, before -4, I could use -5. Between -4 and -1, I could use -2. After -1, I could use 0. I'm just using a number that lies on that specific part of the number line. Okay, that's how I'm going to determine whether it is positive or whether it is negative. Whether it is positive or whether it is negative. Okay, each segment I want to determine. Okay, when I actually, what you're doing is you're asking yourself, when I substitute that, am I going to get a positive answer or am I going to get a negative answer? Essentially, that's what you're saying, right? And when I substitute a value between 4 and -4 and -1, am I going to get a positive value? Am I going to get a negative value? So I'm going to leave those, right? Let's get rid of this. Okay, so what you want to do is you're going to take your initial trinomial. You're going to take your initial trinomial, and that's where you're going to substitute the value. Okay, so x squared plus 5x plus 4, x squared plus 5x plus 4. So you're going to take x squared plus 5x plus 4. And you're actually going to substitute those specific values. So you're going to say -5. Why am I taking -5? Again, is because it's before -4. So it's going to be able to tell me that everything before -4, is it going to be positive or is it going to be negative? I'm going to substitute -5 plus 4. When I do that calculation, let me just double check it. -5, sorry, this is squared. -5 into -5 plus 4. I get a positive answer. Okay, it doesn't matter what the answer is. So since I know that's positive, okay, that tells me that this side, this part of the segment is now positive. Now, generally it alternates, but why did you get -5? So I am simply choosing a number. Remember I said we've separated this number line into like three segments. One is everything before -1. The second is between -4 and -1. And finally, the third is everything after -1. Sorry, this was -4, I meant to say. Everything after -1. So why am I choosing -5? Because -5 is a number that's before that falls part of this part of the number line. Let's call it number 1. Since it forms part of that segment, number 1, I need to choose any number. I could have chosen -5. I could have chosen -6, -7, -100, because it's all before -4. I could even choose like -4,5, for example. Okay, any number before -4. You want to choose like -5. Yes, thank you. It could be anything negative between. Choose -5. It's the smallest number. You're not going to get the biggest number. Choose like 1 before. Okay, between, and you always want to try and choose the easiest. Technically, anything before -4 is not going to be like super simple, but you substitute it into your calculator. Then between -4 and -1, you can substitute anything. Please note, do not put -4 and -1. Remember, -4 and -1 is exactly what made it 0. Okay, so you're going to get 0. Okay, so that's why I'm choosing here -2, for example. And then after -1, the easiest one to choose is 1. Why? I mean 0, sorry, because 0 cancels that, it cancels that, and I'm left with 4, which is a positive. So I know that this is positive. Then I can check -2 when I substitute -2. So -2 squared plus 5 into -2 plus 4, I actually get a negative answer. Okay. Normally it does alternate, but please just double check each one. It's not going to take that long, because there are times where you're going to get plus, plus, and minus, or minus, minus, plus. Okay, rare occasion, but still double check. Okay, so now in this case, I've identified the parts that are positive and the parts that are negative. So my answer now needs to be an interval. Which interval am I taking? Which segments am I taking? Am I taking the positive segments? Am I taking the negative segments? Okay, and that comes down to what the question wants. In this question, this says in this question, they say x squared plus 5x plus 4 less than 0. So they want the negative values. So I need to express in my interval wherever the negative segments are, is what I need to express. So clearly, it's between -4 and -1, expressed in interval notation. Oh, sorry, this is not interval. We say x is between -4 and, sorry, not -5, -4 and -1. Why do I include -4 and include -1? Because the question includes. Okay, the question wants to know when it's less than or equal to 0. And remember, when we say x is greater than or equal to 4, if it's equal to 4, it's going to be 0. But that's fine. Okay, because that's the question includes. In interval notation, I could say x is an element of include both. And that's that. Okay, so parabola and number line explained. I hope that makes sense. If you guys have any questions, please let me know. Okay, that example. Look, honestly, I believe that you can now do that example since we've done it. So try it out and let me know if you come right. But just one thing to note. Okay, you have it as equal to 0. Was it a quadratic inequality or is it a trinomial factorization solve for x question? Either way, you can multiply everything by negative. It's going to be all the signs change when I multiply by negative, and then 0 obviously remains 0. Okay, because you are doing it to both sides, by the way, which is why you're not changing the value of the equation, because when you do the same thing to both sides, it doesn't change the value. In that case, you're going to factorize. So I'm just going to factorize it. If it's an inequality, I think you'll be able to solve it. Okay, factors of x squared are x and x, minus gives us a minus and a plus. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Okay, I need to get -8, so I'm going to choose -10 and +2, and that's perfect. Then when I solve, I say x minus 10 is equal to 0, or x plus 22 is equal to 0, 2, not 22, x is equal to 10, or x is equal to -2. That is what? That is factorization. Why do we multiply the whole equation? Okay, let this thing unfreeze. What do you mean by multiply the whole equation? Why are we substituting 5 into the whole equation? That's just how it is. Negative sum. What do you mean by that? Okay. If you're asking why do we take -5 and substitute it into this entire equation, because we need to determine, right? The equation is what we're working with. Okay, these are values on a number line, and we need to determine when we substitute values into that equation, what are we getting? Are we getting a positive or are we getting a negative? Okay, and express that in terms of an interval. Just know to always do that. If that's not what you're asking, please clarify it for me. Okay, so I just want to revise this one more time. Maybe let's just do it again. It's a little bit maybe higher level. Okay, but you guys, they still need you guys to understand it because it's possible for them to ask it. Inequalities, positive factors don't affect the inequality. That is the main thing that I want to revise, as well as the denominator thing, right? Positive factors don't affect the inequality. So if we look at something like x squared, which is, sorry, if we look at something like x squared, that number is always greater than or equal to 0. No matter what value you have for x, you're going to have to substitute the bracket, guys. Please do not put in your calculator, no brackets, negative 5 squared, and then say that you're getting a negative answer. The reason you're getting a negative answer is simply because, you guys see that? No. The reason you're getting a negative answer is because you're not using brackets. Whenever you substitute anything, you have to use brackets. So when you put in your calculator negative 5 brackets squared, you are going to get positive 25. If you are going to say negative 5 squared, you are going to get negative 25. That's simply because when you say negative 5 squared and you don't attach the brackets, you are saying negative 1 times 5 squared, which is not correct. Please note that whenever you are substituting, always substitute with brackets. That's what I'm saying. When we substitute a value for x, it's going to be in brackets because you substitute with brackets, and therefore this is always going to give you a positive value, or 0, of course. When we look at something like x squared plus 1, it's basically a positive value, and now you're adding another positive value. Okay, that's always going to be positive. A to the power of x, okay, whatever your base is, okay, provided a is greater than 0 as well. Okay, provided that a is greater than 0. But yes, that's why we don't have negative a, we just have it as a to the power of x is greater than 0. Anything, even if x is a negative number, try it. Any positive base to the power of a negative exponent is always going to give you a positive answer. Okay, so this is always positive. And then something like square root x, in this case, x has to be positive. Okay, I'm not saying negative square root x because that's different. Negative square root x, the negative is before the square root. So yes, the final answer can be negative. This is positive square root x. Okay, firstly, x has to be positive. So this type of answer is always going to give us a positive answer because solely due to the fact that x has to be positive. X has to be positive. Why does x have to be positive inside of a surd? Because it needs to be a real number. If it's negative inside of a surd, it's going to be a non-real number and it will have no solution. So let's just revise this, right? If we look at something, if we are given something like this, which is realistic, we have a fraction for inequalities, right? Okay, firstly, before we even note the fraction, we need to identify terms that are always going to be positive and ignore them. 2 to the power of x. Okay, 2 to the power of x is always going to be positive. I can get rid of it because it doesn't make sense. Okay, x squared plus 1, always going to, it's not that it doesn't make sense, sorry. It's always going to be positive. That's why we can ignore it. X squared plus 1 is always going to be positive, so we can ignore it. Okay, it's not going to affect the inequality, so don't consider it. Then if we have 5 minus x, x minus 6, those can be negative. Okay, we consider these. Now, remember, what are we doing? We need to find the critical values that make this term 0. So firstly, that makes any factor 0 technically. So remember, we consider a bracket. When we have a bracket like this, a factor, that's what we refer to as a factor. Okay, so we consider both of our factors and equate them to 0. So similarly, remember when we solved for this factor, once we factorize the trinomial, we equated both to 0. That's exactly what we're going to do, because if this is 0, everything is 0. And if this is 0, everything is 0. So we have to equate each one to 0 and see what makes it 0. So that's why we say 5 minus x is equal to 0. Negative x is equal to negative 5. X is equal to 5 when I cancel the negatives. X minus 6 is equal to 0. I take 6 over, it becomes positive. So my critical values are 6 and 5. So once I have my critical values, that's when I'm going to just do parabola method. X-axis, parabola. Lovely. Insert my x-intercept, if you will. 5 and 6, so that has to be 5, that has to be 6. Then I go and look at the question. The question wants to know, when is it less than 0? Less than 0 is below the x-axis. All right. So I need to express this in terms of x values that is below the x-axis. Okay, so it's basically between 5 and 6, between the x values of 5 and 6. That's when this graph is below the x-axis. So my answer is going to be x is greater than or equal to 5, x is greater than or equal to 6. I included them because the question included, however, one of them is wrong. Somebody tell me what's wrong with this answer and why. What is wrong with that answer and why? Okay, while you guys are telling me what is wrong with that answer, I just want to answer this question. Isn't it -5? So it's not -5 because remember, I took 5 over, it became -5. What became -5? Negative x became -5. So the negatives cancel and then we get 5. You didn't exclude them. Okay, yes, I included them, but why? Why should I exclude them? No problem. Why should I exclude them? Tell me, explain to me. You're saying something about exclude. Something about exclude is along the right lines, okay, of what I'm expecting as an answer. But what shouldn't I exclude? And why should I exclude it? They are less than 0. Okay, not exactly. Okay, so firstly, the question includes, so it makes sense that I included. However, let's get rid of this. Looks funny. It's going to replace it with dotted lines. Okay, so the question again. Yes, very good, because your denominator will be 0 if you include, but not all of them. Remember, my numerator can be 0, okay, because if I include, then it's allowing me, because the question includes, it's allowing for it to be 0. If the numerator is 0, if you say 0 divided by anything, your answer is 0, but anything divided by 0 is undefined. So I cannot, whenever I start a question, if I have the denominator, my first actually thing, I should identify my restrictions. My restriction is that firstly, x minus 6, we solve it like this. We say cannot be equal to 0. X minus 6 cannot be equal to 0. Why? Because of the reason I just mentioned. If the denominator is 0, we're going to have undefined. So the denominator cannot be equal to 0. One second. Okay, yeah. So the denominator cannot be equal to 0. The denominator cannot be equal to 0. And I just solve like a normal equation, but keep that not equal to sign. So it takes it over to the other side. So x cannot be 6, eh? This is a very important restriction that you must identify actually at the start of your question whenever you have a denominator. Okay, so x cannot be equal to 0. So this entire thing is correct, except including x. Okay, so I can definitely say x is greater than or equal to 5. There's no reason for me to exclude 5, but just less than 6. Because if I say less than or equal to, that means I'm including 6. So the way this goes is which values are greater than or equal to 5, but less than 6. It's basically just 5. No, it's 5, and then all the intervals after 5 between 6. So it's like 5.1, 5.2, 5.3 till 5.9. Okay, but if it's talking whole numbers, just 5. Okay, so x is greater than or equal to 5. Why am I including 5? Because when the question includes, I include with the exception of if it's in the denominator, then I exclude it. Even if the question includes, I will exclude if it makes the denominator 0. Okay, hope that makes sense. You guys can attempt the rest of them. Just please note when you are doing parabola for this guy, your graph is actually going to be on the x-axis. Okay, I think we discussed roots. If you go and look at roots, you will see that when you don't have your x, actually the thingy, the turning point is on the x-intercept. It's not like you can't do it below. Okay, because of the absence of x. We have x squared, we just don't have x. Also, if you have a squared binomial, that's also an indication. If you have a squared binomial, that's an indication. Squared binomial means you have two of the same binomial, so 2x minus 1. So this is basically like 2x minus 1 squared. In these cases, your turning point is going to be on here. Okay, and then you can answer accordingly. Okay, let's move on. I don't know, would you guys like to do simultaneous examples? Did you guys go through these practice questions? How did you guys find them? I didn't receive any questions from anybody about them. Okay, are you guys fine with simultaneous? Should I do one example? Please let me know. Okay, cool. Let's go. No problem, right? Let's do one more example. So remember last week we did this one. You can go and watch the video again just to revise that. Let us do. So these are all with square, and then this is a bit of an easier one, right? So I'm just focusing on the square ones, right? Let's focus on the hard ones. The easier ones will be easier. Okay, so all of these examples, they allow for at least one variable to be alone. So remember I said you should always isolate the variable. So let's look at our steps. Do we have our steps? Okay, we don't have our steps, but step one is to always isolate a variable. Okay, higher order question. So this is what you would refer to as higher order, right? With a square, basically, it makes it complicated. So we want to isolate one of our variables. Okay, so when we isolate one of our variables, we want to choose a variable that's completely alone, if possible, or has the least attached to it. So if it's not alone in some cases, just choose the one that has the least attached to it. So it doesn't maybe have a coefficient, or it doesn't have a square especially, or it's not in the denominator or something like that, right? So in this case, it's easy. Remember, this is number 1. This is equation number 2. And I go now to isolate one of the variables. So I choose anyone, whether it's 1 or 2, and I attempt to isolate the variable. So yeah, I want to leave x alone. So x is going to be equal to 3 minus y. When I take it over, this has formed equation number 3. Next step is to always sub 3 into 2. So whichever one you're going to choose to isolate the variable in, whichever equation, call that 1. So wherever I see the variable x, I'm going to put 3 minus y. So 3 minus y is going to go in place of x there, and going to go in place of x in that place as well. So I'm going to say 2 open brackets, 3 minus y, close brackets, squared, plus 4 open brackets, 3 minus y, because that's what x is equal to, times y minus y is equal to 15. Now okay, this is squaring a binomial. I'm going to do it a bit fast. 9 minus 6y plus y squared. If I'm incorrect, please correct me. This I'm also going to do fast. It's going to become 12y minus 4y squared, I believe. And then minus y is equal minus 15. I'm going to take this over, is equal to 0. Okay, simultaneous equations. So if I'm incorrect, please stop me. If you don't understand, I'm basically distributing, right? Distributing each thing. Okay, I'm just not writing each step. Let's take this 2 inside. I'm going to get 18 minus 12y plus 2y squared plus 12y minus 4y squared minus y minus 15 is equal to 0. Let us highlight. Of course, 18 and negative 15 are like terms because they're both constants. Negative 12y, positive 12y, negative y, all like terms. 2y squared minus 4y squared, like terms. I'm going to order them in terms of a highest, what is it? Highest exponential order. So the highest exponent first. Isn't it plus 12 only? Okay, it's not plus 12 because I took 4 times 3 and 4 times negative y, and you get 12 minus 4y. Okay. And you need to multiply that by y. So it becomes 12y minus 4y squared. Why is it 6y? Okay, because that's just the rule. A minus b squared, which is what I have here, that's a, that's b. It's going to be equal to a squared minus, keep the sign the same, minus ab, no, sorry, minus 2 times a times b, minus plus, actually, the last one's always plus, b squared. Okay, so you can learn that shortcut. Alternatively, you can FOIL. Write it out as 3 minus y, 3 minus y, and then FOIL, first outer inner last, all right? Okay, so in that case, let us further simplify. So like terms, again, please, if there's anything wrong, let me know. I get 2y squared minus 4y squared is minus 2y squared. Minus 12y plus 12y, they cancel because it's minus 12 plus 12 is 0. So I'm left with minus y only. And then 18 minus 15 is plus 3. This is equal to 0. Now this is trinomial. I have a y squared, I have a y, and I have a constant, but at my first y squared is negative. So I'm going to multiply everything by negative to change it. So I'm going to get 2y squared plus all the signs change. Minus 3 is still equal to 0. Then I factorize trinomially, equate to 0. So the factors of y, 2y squared, I have to be 2y and y. There's no other options. Okay. Now I have a negative, right? I need to get positive 1, basically. My middle term needs to be positive 1. So because the second sign is a negative, 1 would be plus, 1 would be minus. It does matter where I put it, so I'm going to wait. I'm going to try and determine first, right? The factors of 3 and 1 are only 3 and 1. So I need to use the factors of basically 2 and 1 and 3 and 1 to get 1. So let's just see. 2 and 3 is 5. I need to get positive 1. I can't do 2 and 3 with 2 and 1. Yes, I know exactly what to do. So I'm going to say 2 times 1, whichever the sign is, and then 3 times y. Because remember, what 2 times 1 is 2, 3 times 1 is 3. So I can say 3 minus 2 somehow, right? So that's why I'm going to make this is 3. I'm going to make the bigger number positive. So it's going to become plus 3 minus 1. So when I do outer inner, I get plus 3y minus 2y, which is basically 1y, which is what I have. So now my factors are correct. I have to say, let me take this over to the side. 2y plus 3 is equal to 0. Alternatively, y minus 1 is equal to 0. So 2y is equal to negative 3. Y is equal to negative 3 over 2. Or y is equal to 1 when we take it over to the other side. Remember, I solve for 2y, so y1 and y2, simultaneous. Okay, when you deal with a square, you are going to get 2 values for y and 2 values for x, basically 2 values for each variable. So now that I have 2 values for y, I need to solve for 2 values for x. So remember, once you solve for one of the variables or both of the possibilities for that variable, you want to always substitute it into your rearrange. That's going to be the easiest and best formula to substitute it in. What rearrange am I talking about? I'm talking about equation number 3. So it already has x alone. So I want to solve for x1. So I'm going to substitute the value of y1. Y1's value was negative 3 over 2. So x1 is actually equal to 3 plus basically 3 over 2 is 9 over 2, which is 4,5. If you want to write it as that, then I can solve for the second x value, and it's going to be 3 minus, what was the second y value I solved for? 1. So x2 is going to be 2. Okay, I hope that makes sense. Okay, let us move on. So that's it. Okay, simultaneous and inequalities done. I hope you guys understand, and there's no further clarification needed. Please continue to practice and take it from there. Right, that's how you'll know that it's going well. Let us start. We're going to go through the rules of exponents and the rules of surds. So maybe take like a 15-second breather just to breathe. 50 seconds, 15 seconds is like all we can afford to take as a break. So do you use the y answer and put in your new rule or equation? To use the y answer and put it into your new equation. Well, yeah, you just put it into the rearranged equation. Technically, this y value, so since you solved for y, you can substitute into any of the equations, to be honest. Just want to simplify your life, all right? If you want to, the simplest one to substitute it in is into number 3. That's all I'm saying. So yes, you solve for y. Now that you have a values for y, you can substitute it into this. If you substitute it there, then your only unknown will be x, and you can solve for it. It's just that in the rearrange, you already have x left alone. So you just have to substitute it for y, and you'll get a value straight away. Okay, rules of exponents. The first one we're going to go through is if we have, okay, so obviously here it's expressed as a, where a is any number, right? If I have, but basically it's saying if I have the same basis and different exponents, same basis, why did I use x and b and not x and y? Okay. So again, if we have same basis, different exponents in multiplication, very specific criteria, same basis a, okay, whatever the exponent side doesn't matter. In multiplication, same basis in multiplication, I can write it all under one base and add my exponents. That's the rule, right? The reality of it is if you want to answer these questions efficiently, you need to know these rules by the back of your hand. You need to be flawless with these rules, okay? You need not confuse them, okay? Then in the question, obviously, you need to work on the questions as well. But starting point, you need to know these rules and how they work 100% by heart. You cannot have a cheat sheet because the rules of exponents are not given into the exam. Okay, so you need to know these rules and how they work in the basic examples as well as in maybe questions, of course, as well. So same base, different exponent, or just same base in multiplication. We can write it under one base and add the exponents, right? Then we have same base in division under one base and subtract the bases, the exponent, sorry. That's rule number 2. So rule number 1, rule number 2, let's go to rule number 3. Before we move on to rule number 3, let's just discuss the reverse of this. The reverse of this rule, which is basically, you need to know that when you have, I'm going to choose b to the power of x plus y, you can go backwards and actually simplify this to b to the power of x times b to the power of y. This one is very important and very, very common. B to the x times b to the y, okay? So you can go backwards as well. I just changed it from a to b, it doesn't really matter, it's any base, right? So b to the x plus y is equal to b to the x times b to the y. Please keep that in mind. Same thing with this guy, b to the x minus b can be written one of two ways. The first way is actually better. It's more common to do it at this grade, at grade 11. So remember, we could have added these as well, technically. We can have b to the power of x times b to the power, no, sorry, I already have the times b to the power of negative b. Negative b, okay? Alternatively, it's also b to the power of x divided by b to the power of p. The first number goes as numerator, second number and denominator. But actually this one is really nice because it's common in helping us solving questions. So even if you had to go backwards and add them, you'd say b to the x plus minus b, which would be bb, x minus b. So we didn't change the value, as you can see. Okay, so that's good to note. Then we have number 3, which is known as a power to a power, which is basically when we raise an exponent to another exponent. So in this case, right, we have a to the power of x to the power of b, a to the power of x to the power of b. So a to the power of x is a term, and then you're raising it to the power of b. In this case, you always multiply the exponent, so x times b. The power of x to the power of b is going to be x times b. Let's look at number 4, which basically says a to the power of 0 is 1. And it's saying that a is a variable. It can be any number. So anything to the power of 0 is 1. What is 1 million billion, trillion, to the power of 0, 1. What is 7 to the power of 0, 1? It does not change. Okay, let's look at example number 5. Right, so these are exponent rules, important for you to have them memorized. So example number 5, okay, it's basically writing a negative exponent as a positive exponent and vice versa. So whenever we have a negative exponent, so in this case, I have a to the negative x. If I want to express this as a positive exponent, I have to take it to either the numerator or the denominator. So currently, any number written as a fraction that already is not a fraction, if say, is all a fraction, because we can all just divide it by 1 and it doesn't change the value. So like a to the negative x, right? A to the negative x, a to the negative x over 1. What am I trying to say? I have no idea. A to the negative x over 1. Okay. So firstly, you need to I don't know what I was saying. Okay, but basically, let's just go back. Numerator, denominator. Whenever you have a negative exponent, you just need to swap it. Take it from, if it's in the numerator, put it in the denominator. If it's negative in the denominator, put it to the numerator and you can make it positive. So in this specific case, right, I'm going to flip these two basically. I'm just going to take that to the bottom. So when I take it to the bottom, on top, I'm left with 1. Okay, and the bottom, I'm left with a to the positive x. That's basically it. If I take it from denominator to numerator or numerator to denominator, I change the sign. Okay, so if I had to have just had to have this, right? If I had this, okay, I want all of them to be positive. So basically the negative ones, I just flip them. So for example, B, I take it to the bottom. So on top, I'll have a squared, right? And at the bottom, we can see that C is positive at the bottom, so I can leave it as well. Maybe I want to write it alphabetical order, but it doesn't matter for now. B, however, I take him to the bottom and he becomes positive. That's how you do it, right? Then we have D to the negative 4, I want to take him to the top. So that's how I do it. I take it to the top and make it positive. Sorry, I want to make it positive, so I have to take it to the top. And that's how I do it. Can you do the reverse to rule number 4? Okay, there's no reverse to rule number 4. You just have to understand that anything to the power of 0 is actually 1. That's the main thing. What about 0 to the power of 0? Okay, don't worry about 0 to the power of 0. It's undefined for now, but you won't be responsible. You won't need to know that. Please explain number 3. Can you reverse rule number 4? Make it positive. Okay, you can just put in your calculator. Okay, what exactly are you saying to put in your calculator? But yes, okay, the reversal of rule number 4, let's go through as well. Just move this up. So the reversal of rule number 4, you see, it seems very simple in the rules. In the question is where it can get tricky. So I'm going to do B. I'm going to choose numbers. Okay, I'm going to say B to the power of 10A. B to the power of 10A. So this guy I can simplify as B to the power of 10 times B to the power of A. That's important to remember. So again, it's basically B to the power of X times Y is equal to B to the power of X times B to the power of Y. Okay, so just note that. Let's have a look at this. Okay, so this is distributing sort of an exponent. So yeah, remember, you're not just going to get ABX, AB to the power of X. Yeah, when you have a multiplication, okay, a multiplication and the whole entire multiplication has an exponent, you will raise each one to that power, as can be seen. Okay, so A to the power of X times B to the power of X. And similarly, when it's in a fraction, this is really important, right? In all subjects, not all subjects, maths and physics, in a lot of topics, you can come across something like this, right? And that as well, you need to take the power to each term. Many people forget this. So when you have a fraction, exponented, or a fraction with an exponent, you need to, so just say you have a fraction squared, you need to square numerator, square denominator. You have a fraction cubed, you need to cube numerator, cube denominator. You have a fraction with the power of 10. You need to take the numerator, put it to the power of 10, take the denominator, put it to the power of 10, and that's how it can be written here. Okay, as well as the reverse, of course, in this case. So we have, let's just say b to the power of c, and no, let's choose a number. B to the power of 5 and c to the power of 5. This could be written as b times c whole to the power of 5. And the reversal of this one, I have a to the power of 6, b to the power of 6. I could write this as a over b, okay, to the power of 6. Okay, makes sense? You're referring to number 5, sure, but like if you have variables, for example, then you can't put in the calculator. Let's talk about, okay, we'll end like in a couple of minutes. I have load shedding at 12, so you can't go past 12. So we'll end by like, let's just say as close to 12 as possible. For those who don't mind staying, please do stay. If you need to leave, you can leave and watch this later. Let's talk about simplifying surds. So if I have something, okay, firstly, if I have root 4, somebody tell me what's the answer of root 4? 2, excellent. Okay, why do we know what is the answer of root 4? Because 4 is a perfect square. Okay, very nice. Since it's a perfect square, we know that 2 times 2 is 4, or 2 squared is 4. So that's why when we say square root 4, we know that we can square root it to 2. Similarly, if I asked you what is square root 64, you'd say 8. Okay, because why? You know your perfect squares. At least most of you do. All right, so square root 64 is 8. Okay, however, what happens when I have square root 50? When I have square root 50, okay, it's not a perfect square, so I can't get a straightforward answer, but I can simplify it. Okay, now maybe many of you currently just utilize your calculator to simplify surds if you need to, or your calculator already gives you the answer in simplified surd form. However, if there's a question that requires you to do it without, like to show your calculations, you need to know how to simplify surds, and sometimes it's faster than doing it in your calculator, and time is important, of course, right? So what you basically want to do, okay, is you want to write whatever's inside of a surd as a product with a perfect square. It doesn't always have to be the biggest. You can simplify it numerous times, but most likely you're going to get the highest correct one. So tell me, okay, so when I say multiply to the perfect square, I basically mean that, let's consider 8. 8 is not a perfect square. However, if I consider my perfect squares 1, 4, 9, blah, 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 I can note that, okay, I can actually write 8 as 4 times 2. Okay, why is it perfect square? Because it's 2 squared times 2. Okay, it's 2 squared times 2. So it's a perfect square times another number. So tell me someone, not in exponential form, just 2 numbers that I can multiply. So that's why when I mean product, I need to write a multiplication, and one of those factors need to be a perfect square. So someone tell me, how can I write 50 as a product with a perfect square? Exactly. Okay, brilliant. 25 times 2. So now I can write this guy as 25 times 2. Okay, and actually we're skipping a little bit ahead, but let's just quickly go through the first rule of surds. Okay, the first rule of surds states that, actually the backwards way, but it's fine. When we have square root a multiplied by square root b, we can write it all under one surd as square root ab. So let's work backwards, right? If I have square root 10a, I could write this as square root 10 times square root a, as long as it's multiplication, right? So now we see this right here. Whereas I have square root 25 times 2. So I can actually write it as square root 25 times square root 2. And then why do we choose a perfect square? Of course, so that we can square root it to simplify the number. So square root 25, that can simplify to 5. And then square root 2 actually just stays at square root 2. It's in its simplest form. Okay, let's do another number quickly. Let's look at square root 80. Now let's look at okay, sure. Let's look at square root 80. Tell me, somebody, how can I write square root 80 as a product with a perfect square? What can I write it as? You don't have to think big for this one, by the way. Okay, 16 times 5 works as well. Okay, I was thinking also, even if you don't go the biggest, right? So 16 times 5 works one shot. So let's do 16 times 5, right? Brilliant. 16 times 5. Now, you actually don't have to show this step, right? Especially if you're simplifying search. You don't have to show that step for that rule number 1. You can just consider, okay, when I take out 16, I have to square root, because currently it's in the square root. So when I take it out, it needs to be square rooted. So you can simply simplify to 4. 16 outside of the square root is 4. 16 inside of the square root is 16. 4 root 5. Again, you could put square root 80 in your calculator. It would give you the simplest form. Okay. If there's a question that requires you to not use a calculator and show your calculations, you might need to show this. Okay, you could technically see it from there to there. Technically, but just know it. Let's just do it quickly the long way. If you had to choose 4, we have square root 4 times what? 20. And this is going to be 2 square root 20, right? Okay, because you're taking 4 out, you square root it. Okay, or alternatively, you can write it like that if you want. Now you realize, oh wait, shucks, 4 can go into 20 as well. So I can do this again, right? So now I have 2 times, essentially times, I'm going to say, okay, what's the highest square that can go? It should be 4. I'm going to say 4 times 5. Okay, now I can take 2 out again. And when I take 2 out again, remember, I have the 2 that already exists. Taking 4 out of a third makes it 2, and it's in multiplication. And then we're left with inside of the third, square root 5, which is now 4 square root 5. I hope that makes sense. When you take 4 out, it becomes 2. Okay, cool. So that's if you simplify. All right, let's end it there. We will start off next week, continuing fractional exponents. Okay, important as well. Finishing third rules and, okay, third equations, which is much more simpler. And then practicing our knowledge of third rules and exponent rules to do these hard questions from past examinations. The ones that would probably make some of us cry. I'm willing to put money that some of us have cried looking at these questions. But okay, cool. So before we leave, and if my lights don't go, tell me, please, what are you guys currently busy with? Who has started trigonometry? Who's still busy with exponents? Please tell me, what are you guys busy with? Trig, Euclidean. Euclidean we will be doing after trig. Actually term 2, but I understand if your school started early, it actually makes sense. Okay, parabolas of functions, exponents, trig, starting trig on Monday, nature of squares, trig, b by inequalities and thirds, exponents, over the exponents, how to decide nature of roots, but now it's our last topic. Trig, nature of roots. Okay, so some of you are still busy with algebraic expressions, some of you are in exponents, few of you are in trig as well, and then some are like way ahead in Euclidean. The person that said they are in Euclidean, have you finished algebraic expressions, exponents, equations, and inequalities, and trigonometry. Zahira, please tell me, if you started your Euclidean, does that mean that you finished those previous 3 topics, or did your teachers just leave one of them for next term or swap it or what? Skip tricks. Okay, makes sense. Okay, cool. So let us end it there. And yeah, just look out for, I think maybe this is the class that actually, as we were talking about the timetable and also the notes before. Okay, I'll send the exponent notes now, then you'll have access for it. Oh yes, these PDFs, I'm going to send it now because they knew. Sorry, I forgot to send it in advance. I think this is the class that asked for it. Also, the timetable thing. Sorry, I'm overestimating my time in the week, so I have very little time in the week. So what I'm gonna, yeah, I'll just send the topics, right? Inshallah, I'll send it by tonight. Just the order in which we are going to do things so that you guys can plan accordingly. Okay, the notes, you can find them. I'm going to upload them to a Google Drive. The link for that Google Drive can be found in the group description on WhatsApp. So the grade 11 maths group that you're in, if you go to the description, you will find the link which says Google Drive. You click on it, you'll have access to the notes. Okay, cool. Perfect. So thank you guys so much for joining. It's been a pleasure. I will see you guys next week, inshallah. All the best. Have a good week of school and yeah, enjoy whatever topic you guys are doing. Cool. Jazakallah khair. Thank you guys so much.